Okay, today's theme is the modeling of a cognitive system, which is the ground floor of all stock markets. The basis is the background you have in the physics of modeling systems based on quantifiable physical laws that you can understand system behavior, basically. And with system behavior, I mean anything from engines to penguin colonies to car crashes, rockets, nuclear bombs, bridges, like anything that you can model, basically. Because the beautiful thing is, like, if you look at a broader spec, like, the stock market is also just a system. However, like, the approach on how economical forces look on the stock market, the approach itself, the angle they are taking is like completely the opposite of what you find in physics and engineering. Because the way engineers look at it is that you start basically with understanding the physical laws, also the nature that defines all kind of system, and it's basically three major parameters that's important. It's speed, its position, and its acceleration. Like more advanced system, like in unified acceleration sphere as the gravitation is, like the like the change of acceleration is not that important, but it becomes very important out in space. However, here we just need to think about position, speed, and acceleration. And out of these three components, you can pretty much understand any kind of system and model any kind of system. Even though there's like some weak spots, like turbulence, for example, almost impossible to model. However, with these three fundamentals, you can establish graphs, you can set up differential equations, you can model anything from how you crush a beer box to the nuclear bomb to a space rocket to the development of algae in the North Sea, or let's say like the coconut plantation population here in Sri Lanka. Funny thing though is that you define the system after you understand the basics. So, like, you can run a finite element method and crash a car, and the simulation of that car will be pretty much exact as it happens in reality, because you understand the basics. So what comes last up is the model, and the model is based on the graphs, which again is based on the bottom of the laws. However, in financial system, you have the top-down approach. Like, the first thing actually people look at is graphs and models. They'd be like, yeah, here's a cool graph, look at this graph, it's almost like this other graph. Like, this is some kind of model. And it's just wrong, because you don't understand the basics. And the fun thing is, like, the same way you have forces in physical systems, these forces, when a car gets crashed, for example, they get redistributed around in the deformed vehicle. What you look at the market is that the market consists of sentiment. Like, the forces in the stock market are sentiment. The same way that when a car crashes into a brick wall, it crashes, it gets a lot of deformation, like permanent plastic deformations, which relocate the forces in the system. The same way happens when the stock market crashes or the stock market moves. It's basically a relocation of the sentiment, like what people believe in and how they value goods, commodities, and equities. So the core belief in this whole research is that we can apply the logic of physical nature to the stock market. Like, everything in the stock market, the sentiments, changes, can be modeled by the three basic principles of position, speed, and acceleration. And first, when you understand the basics, these three principles, you can start with a bottom-up approach and model the top game, which is the graphs. And basically work the other way around than what most economical people are doing. They're just looking at the graphs, drawing some lines, looking at this, looking at that, overlays, comparisons, which sort of works to a certain extent because people are always looking at the same, but they just don't understand the fundamentals. Like, we're going to dig into the fundamentals, and we're going to solve this stuff. So, that's me. Thanks for now. Over now from Sri Lanka.